to today's episode of Rawkode Live. Before we get started, I just want to take 10 seconds to say thank you to my employer, Equinix Metal. Equinix Metal is a bare metal cloud that you can try it for free. Today, I am giving you Rawkode Live as a coupon code you can apply when you register Equinix Metal, which gives you $50 in credits. And $50 allows you to spin up our smallest instance for C3 Small for around 100 hours, give or take, depending on what you do with it. Or you can splurge that all really quickly and go with our N2 extra larges with a whopping 384 gig of RAM. If you are not watching live, or even if you are watching live and you want to chat and ask questions, we do have a Discord, but we do encourage comments in the YouTube comment section too. And please remember to subscribe and thumb up this video. That would be very much appreciated. Today, I am going to take a look at Pulumi, and I have the pleasure of being joined by two engineers from Pulumi themselves, Lee Briggs and Paul Stack. Hello, how are you both doing?
Good, thanks. You?
Yeah, I am doing very well. It's 5 p.m. in very dark Glasgow, but not too bad. How about you?
The same. It's 5 p.m. in very dark Northern Ireland, and it's miserable, as always, in the winter.
Yeah, and I'm... sorry, go ahead.
No, I was just going to ask where you are.
I'm in Seattle. Yeah, despite the... you probably hear that hybrid Northern British and American accent. So I've been here 3 years now, and I swapped American miserable weather for... English miserable weather for American miserable weather.
Yeah, I was going to say, between the three of us, we're in just murky, dark, rainy places, right?
Absolutely, yeah, 100%.
All right, well, could you just both take 30 seconds each, introduce yourselves, say what you do, and then we'll kind of talk about what we're going to cover today and take it from there. Lee first, on you go.
Yeah, so I've been at Pulumi just gone 6 months, and I guess my new responsibility is community engineer. So I'm kind of building out our content, external content, and our workshops, and how to use Pulumi, and showing examples. Before that, I was working with Paul on the what we call the platform team. So that's our open source CLI and all the SDKs and the providers that we currently support.
And as Lee said, I'm Paul Stack. I'm Stack72 on Twitter and pretty much everywhere on the internet. I predominantly work on the platform side, so I have a lot to do with the providers and the CLI, and I'm usually the one that causes the bugs in those parts of the system.
Nice, awesome. So why don't we kind of let's go back to the basics, right? Why don't we give a pitch about what Pulumi is, right? I've got the homepage here. It says modern infrastructure as code. So what does Pulumi do? What's the problem it's solving, and what makes it different from other tools in its marketplace?
Yeah, I'll take this one. If you're familiar with infrastructure as code, you've probably used some of our competing products, and they generally either use a configuration language or a DSL, like a wraparound language that allows you to kind of do declarative infrastructure as code. And Pulumi does not take that approach. It uses imperative languages or languages that you may be familiar with in your software development lifecycle. And it does some magic in our engine to turn that imperative code into declarative infrastructure. And so it dramatically helps people who are already familiar with standard software development languages like Go, the .NET ecosystem, the Node.js ecosystem, and Python. It allows you to kind of really quickly iterate on that infrastructure as code. And I think we're hopefully going to see that today.
Nice. So what is our goal today? What are we going to do?
As I said on Twitter, this is a very lofty and an ambitious goal. But the idea is we're going to kind of use Pulumi's brand new automation API to show how you can build a like a reusable command line tool to kind of create infrastructure. And this is a good example of something that you might build if you are building a platform. So something that the State of DevOps report came out last week that Puppet does, and I think it was a very high number, like something in the 70% of organizations are trying to build these platforms, like user-friendly ways of provisioning infrastructure. And one of the great ways is that one of the great things about Pulumi is it allows you to do this in languages that you feel familiar with, but also make them reusable and share them between multiple people.
If you think of what like Foreman used to be in the VMware and the Metal sort of area, think of like being able to build that type of abstraction, but specifically for your infrastructure and your company, and be able to like drive that using Pulumi.
So, Paul, being on the platform team at Pulumi, then, is this something that you're experimenting with yourselves on your own platform as well?
Yeah, so of course, like this is something that's actually going to potentially be used to replace some of our like infrastructure testing, and because we've built up this sophisticated like infrastructure testing suite that runs via Go test, and we think that we can probably swap that out in the future and be able to use this runtime API to be able to do it, because it actually gives you access to the Pulumi commands that we use, and they're wrapped in a way that makes them a lot more usable and friendly, rather than like format.sprintf, Pulumi up, and so on.
All right. So I mean, my naive understanding is hopefully going to get better as we go, but we're going to build a command line application that has some of the Pulumi API or runtime components baked into it, allowing me to modify my state of my Equinix Metal hardware and store that state somewhere and allow me to make updates to it. Is that naive guess roughly what we're doing?
That's a pretty accurate representation. And the way, like, I think I, as I said on Twitter, like I have intentionally done very, very minimal research here. So this may not be successful. I think an hour and a half is pretty optimistic, but we'll see. But the idea here is to show how, you would go through this process if you were going to, help. Let's say you're in a development organization and you want to provide the capability for people who aren't familiar with infrastructure as code to just create testing environments or create just even Equinix Metal instances to provision them nice and easily without having to write a bunch of like a language they don't understand. You might go through the process that we're going to go through today, basically.
Awesome. Let me get my screen on here then. So it's great that you said nothing is really done in advance, and we're pretty much winging this big time here, because at the start of at the start of every episode I say, hey, we don't really do anything up front. This is transparent. We try and take you through every step that you need to do yourself. And what I normally do is say, here is what we actually did do in advance, but in this case it's nothing. So I've got an empty GoMod file, I've got an empty README file, and an empty CLI directory. So we are starting from, as we'd say in Glasgow, hee-haw.
Hee-haw indeed. So I think the first thing that we're going to want to do here is, instead of just kind of like diving straight in and building a CLI, I think what we probably want to do first is build a functioning Pulumi program, so that we can get all the debuggability. I mean, you're not exactly going to build a CLI right away. So I think the best thing to do is just create a new empty directory called program, or something like that. I don't think that will work because you've got things in this directory. So you'll need an empty directory.
You can pass -- force. So like what the command that we should run here will be Pulumi new, and then we can say packet dash whatever the language we want to use -- force, and Pulumi will scaffold an application. Now, David, you'll have to forgive us here. I know we have to rename these templates to Equinix, but we'll get to that when we rename the provider for you.
Don't worry, our team is still doing that ourselves now, and we've been Equinix Metal for about a month, so it's not an easy process, but we're getting there. So let's just call this new thing. I'm not fussed about the project name.
Yeah, not at all. Dev stack yet.
Make it very secure.
Password ABC.
Yeah, 1, 2, 3, bang is usually mine for demos.
It looks like you're storing your state in a bucket. Is that right?
Oh shit.
No, it looks
Probably
local.
need to log in.
Local.
Probably need to log in.
Let's do
There
that.
we go.
We don't want to use my production bucket, my Neo bucket for that. So,
Yeah.
And all I need to do, in fact, it's fine. Let's just pop this open. So, I'll just rename that stack because I'm pretty sure I've probably already got a dev one, and we'll call this live. I won't have a live stack, so we should be okay from there. The encryption salt won't need to change, will it? That should be all right.
Should be fine.
Okay, so we have an empty Pulumi project and go.
Yes.
Are you just wanting me? So you said what we're going to do is, write this as if it is provisioning and infrastructure as code with Pulumi, and then we're going to try and CLI it. So should I just spin this up a fresh device with some basic user data?
Yeah, I think the best thing to do is spin up a fresh device. So you'll have to obviously do your if you want to create a new project or a new organization. I generally just when I'm interfacing with Packet, I do a lookup project.
Oh, I normally just pass it in as config. I'll just do that because it's what I'm familiar with.
Yeah, just go down the path that you're familiar with, and then the once the project's done, then just new device. I think is probably a good start.
This is great because now I get to just do Pulumi how I do Pulumi, and then you can fix all my broken bad habits as well while we're here.
Or the alternative is that Lee and I actually learn from how we learn.
All right. So normally I would say project ID. It's Pulumi stack in it because I broke that. So give it my. All right, then we set my project ID in a config. I should update our Pulumi live file, which I'm happy with. Nice. Okay, so from here, what I would normally do, and I normally do this in TypeScript, so this will be fun for me, but packet.config. So in TypeScript, that would be Pulumi. Oh, yeah, Pulumi.config. Wrong object.
You need to assign it to a variable. So,
so the Go SDK is a wee bit more verbose than the TypeScript examples.
All right. How do I get the config and Go?
You're expecting me to know this stuff off the top of my head. Let me find this example right here.
All right. I'll go ahead with the device stuff.
So we should actually be able to just new up. So config.new, pass in a context and an empty string, and that gives you access to everything that's inside what's going on in here. And then you're able to pull everything out of context of the config package. So
I didn't see a config package.
Oh, it's in a separate.
You need to import it. It's in a separate, so it'll be
Of course.
It's in Go, so you need to import Pulumi/config.
Yeah, we go.
There we go. So now you should have config.new.
There we go. Right.
Pass it in context. And an empty string, so you actually access the top level namespace. There we go. Now you can actually pull the config variables out.
Is this the same API, which I imagine it is? Yep. So require project ID, which is
maybe capital R, just because it's Go. And it'll probably return an error.
Yep.
Oh, no, it doesn't. Require doesn't. I apologize.
Config doesn't either. Right, nice. Okay. So that's good. Now I can create a device. So we'll say device, and I'm going to assume this will give me an error.
That definitely does give you an error, yeah.
New device. Yeah, see, we're cooking now. All right, context, name. So we'll call this. What are we going to deploy to this? Does it matter?
Rawkode live. No.
I think you could just give it. It's just any kind of and then it will take a struct.
A pointer to packet.device args.
There we go.
All right, let's see. Facilities, AM6.
Is there any specific reason why you choose AM6, or is that just the one that's closest to you?
Yeah, Amsterdam's closest to me, that's all.
Okay.
Plan, let's go C3 medium x86. What else do I need? My project ID, which I got here.
So we probably need to stop here because the Go SDK is got custom types. So you'll see the facilities. It's probably telling you that it doesn't take a type of array. It takes a Pulumi .string array. And then you can do a normal Pulumi.string. If you're familiar with the AWS SDK, this is kind of a similar kind of pattern. There we go.
Oh,
And
I did
then
it.
that's
it's just missing something, right? That's all I was complaining about.
so
Well, you need to wrap the strings in Pulumi.string as well.
So your plan will be a Pulumi.string. There we go.
Ah, you can tell I don't use this API much.
You get used to it. I kind of like it. The strong typing is really, really helpful. I think project ID. Oh no, you need a capital D there.
There we go. What am I missing? It's just not used. Okay, so that's enough.
And then we need to pass that device args as a pointer. Yeah, there we go.
There we go.
Okay, let's just clean this up. So we don't need any of this. And then, let's keep that export so I know how to do that. Otherwise, I'll be looking that up too. So this is Go. So we need to do if air nil. Oh, no. There we go.
That's a Scottish nil.
Yeah, and then you just need to return the error. So this Pulumi.run just returns an error. So you should just be able to return the error there. Yeah.
All right.
Go.
And then if we export the device dot access public IP4, we have a device, right?
Yeah,
that should work. Yeah, absolutely.
You know what? I mean, I haven't used the Go API, SDK, whatever we call that, much, but it's got some nice qualities to it. I mean, I'm familiar with Go. I just need to learn these little Pulumi strings.
We might be missing a couple extra details. So we haven't passed in an operating system.
Oh, I would expect the type system to moan at me for that, actually.
I think that's done. We have this new enum stuff coming, which should help with this, but I think that will probably happen at...
it's done at runtime.
At runtime, yeah.
Yeah, and then we also have to pass in a billing cycle.
Yeah.
Okay. Are there types for that, out of curiosity? Let's see.
There are not currently as of today, but very soon there's work that's actually undergoing at the minute that'll allow you to do that.
Ah, nice. All right, so hourly, and do we want to just pass in some user data as well?
Yeah.
Well, yeah, go on.
I would. My intent is to get very ambitious and spin up a Kubernetes cluster. So, what I would do is declare a new, just have a new string that defines the user data above this, and then, and I would make it a string literal so that you can do multi lines. But yeah, like you can just pass in Pulumi.string. Yeah.
Okay.
And then I think you need one more thing according to the packet API, which is hostname.
I think it auto generates.
It should be based on the name that I provided, but we'll do that too. Let's not test these things just now.
Yeah. So we can leave the user data empty for now, and then we'll install Docker on Ubuntu shortly, I think.
Well, let's just make sure we don't break anything, I guess. So
just make it an empty, yeah.
Bin bash, yeah.
Empty shebang, yeah. It's perfect.
I always like to be able to test it without the export as well. So we'll just run Nginx and interactive dash yes. Okay, so that should give us, once we run this Pulumi program, we'll get an IP address as the export. We should be able to hit that in the web browser. Job done.
Here's the moment of truth.
All right, so Pulumi API token. Let me get that sorted first. So Pulumi config set secret packet API key. Let me grab that over here. It's a packet API key or packet off token. I can never remember. I'll need to look that up.
Packet off token, I believe.
Yeah, packet off token. Good. Okay. Off token.
So an interesting question for you here, David. Any specific reason why you're using setting that specifically to your config file rather than just letting Pulumi pick up your environment variables?
I don't set environment variables.
Okay. And it needs to be packet : off token.
Yeah, I was just going to come in and modify it here. Is that okay?
Oh, that's fine. Yeah, that's perfect.
Well, because it's secure, that should be... Yeah, it should be all right, I think. Let's see. Well, let's test it.
Yeah, let's give it a try. Why not?
Yeah, I generally don't use the environment variables and generally stick it in. Plus, it's encrypted, so it's safe, right?
Well, it is. So, like, it's actually using our secrets engine built in by default. So you can see every time you run Pulumi up, it's actually going to ask you for the passphrase to make sure you have access to run Pulumi up. So it's safer, should I say?
Yeah, I'm just used to using env chain and storing it all in my keychain. So
I don't know that. So there's something I'm going to have to learn from you at some point.
yeah.
Yeah, env chain's pretty cool.
So what you'll notice now, this is taking a second, and it's because it's building a Go binary. So it's basically doing a Go build. Behind
In fact, you could probably look at top and have a look and say, oh, it's too late. But you could have looked and seen it actually doing the compilation.
All right, so we're going to say yes to creating a new stack and yes to creating a new device. It's going to go away into its thing. I guess what I can do right now is move this tab over here too. Oh, unrecognized user data format. Is that because I put a new line in, isn't it? I knew that was ambitious.
Yeah.
That's our API. It's very specific about that first line, and I just went. When I typed it, I was like, I wonder if that'll work, and I should have just realized that was silly. Anyway, it's going to work now. And what I will do is we have a browser here, and I've got my console. That's stuff we can ignore. Let's hit yes.
So we should actually see a device actually being created now.
There we go.
There we go.
Beautiful.
Easy. All right. Don't get too confident yet. That's what I should tell myself. So that says creating here. We can see this here. Here's a question then. Something I've noticed is I use Pulumi quite a lot now, and I always see this message trying to leak through to me and never quite see it. How do I get that out?
It should.
My font is so big.
It should dump it after the update is finished.
Okay.
So you should see that in the diagnostic output. Yeah.
Yeah, that's a debug statement that's actually leaked through from the upstream provider that we use to build our SDK from.
All right. Okay.
So of course we pick up the entire scheme of the SDK and are able to use that. So it picks up the debug statements as well.
Nice. Okay. At least I understand why it's there now, and I'll look for it in the output afterwards. So this is going to take. We're using Ubuntu 20, so probably less than 90 seconds. So why don't we talk about what's next then while that's spinning up?
So it depends how ambitious we want to get here. So my intent was to show how you could bootstrap a Kubernetes cluster with Rawkode. We could go down that path and create 3 masters and then actually bootstrap the cluster from this Pulumi program, or we can go into building the CLI right away. And it's your live stream, David. So I'll let you decide on the path you want to go down.
Right, no pressure then. So
feels like an old style RPG where you choose your next move.
It's basically it's one of those books, those choose your own adventure books, exactly.
So let me understand what's involved in the RKE bit, right? That's really just wrapping our device args and provisioning in a loop for 1 to n times and updating our user data to be install RKE, right?
So it will. So there's a community provider that I built. So essentially, the user data will install Docker, and then we'll do, as you said, we'll loop through all of. We'll do a loop. So we'll do 3, because obviously Kubernetes needs 3 masters. We'll do 3. 3 devices, and then we'll pass the output of those devices to the second provider to bootstrap the cluster. And I've used this regularly outside of Equinix Metal, so I feel reasonably confident it will work. But the other thing that we can do is we can start implementing the CLI and do a create instance command just with what we have here, which I think gives the same kind of feel to it, basically.
Yeah, I like that plan. Let's start with the CLI version of this, and then we can try and make it a bit more cooler, bringing in the other provider and the other stuff. I loved your caveat there. I've used it outside of Equinix Metal, immediately saying if it fails, it's your fault.
Absolutely, yeah. I was actually going to say it worked on my machine, and then I was going to blame your laptop. But yeah, I think we building a CLI. I think is a pretty good thing. Look at that, easy. Record time.
So it's important to say here, Lee, like we haven't talked about anything around state management, because like if there's anyone on the stream who's new to state management, then by default we're actually storing the state. Pulumi knows that you have built a packet device, and if we went to, or excuse me, an Equinix Metal device, and if we actually go to the portal and we delete that device, then Pulumi will actually try, if we refresh it, Pulumi will actually try and recreate it. So, there is state involved in the infrastructure management here. And I know that there are some people who are not hugely happy that state is involved and state is kept, because they believe that, you should be able to query against the specific cloud or the specific metal provider. But there is actually some state that's involved here.
Yeah.
So I ran a Pulumi up there, and you can see nothing has changed. There's nothing it wants to do there. So yeah, that's valuable to know for sure.
So I think you created a CLI directory before. Let's go ahead and start bootstrapping a CLI. I think
I just realized I'm using the editor that didn't give you access to type anything.
Yeah, I was feeling a bit shut out by this whole affair, to be honest.
Let me close that other one. That was my mistake. So good. That's the not live share one. Okay, so now you're back in the game. All right. So what's the step one to make this a CLI then?
Inside your CLI directory, I think you already added a Go mod, I believe. Yep.
Nice.
So I think I like to lay out. So I'm going to use Cobra and Viper to do this, and I like to lay out these things in a specific way. If you've used it and you like to lay it out in a specific way, then go ahead. But it's totally your call.
So no, let's learn your way. Let's do it.
So inside the CLI directory, I would make a CMD directory. And then in here is usually the name of the CLI as a folder. So if we call it something hypothetical, like we called it CLI right now, maybe we'll call it Metal CTL, which will mean you'll have to update the Go module path in a few minutes to. Okay. And then in here, you have a main.go, which kind of bootstraps your actual Cobra application. So this is a package main, and then you'll need to import Cobra, which is github.com SPF 13 Cobra. Yeah. And then you need a configure CLI function, I believe, first. I think CLI needs to, I think it has a specific API, so it needs to be C and then capital L, capital I. I guess
you want to take over the typing and get
I could just do that. That would be easier. Yeah. I thought we were doing this together. I thought it was just and then this returns
I wish I had a beer here now.
Cobra.command, I think. It isn't auto completing, I don't think.
Because we haven't
actually installed the Go mod.
Yeah, I'll run a Go mod download just now. But if we try and save that, VS Code is going to do this really annoying thing when it tries to remove unused imports as well. So.
Of course. And so then here we're going to create a root command, which again returns a cobra command. I'm just referencing a previous layout that I have, basically. And then long create things in Equinix Metal. Okay. And so at this point, we just need to actually return a root command. And that should be pretty much it for the configure CLI command. And then I think, let me root command configure CLI.
I believe that go mod needs to go at the top level, David, not inside the. Oh no, I take that back. I apologize. It's already at the top level of the CLI directory.
Yeah, I think we'll need to save this and just do a first build to get it to pull that dependency down, and then we should get our autocomplete, hopefully.
So for those not familiar to Cobra, Lee, why would you use Cobra over something else in Go?
I really like Cobra because it allows you to build CLIs that kind of follow like a 12-factor app approach. So like you can do things like have configuration files and bind things to environment variables. Like it might be overkill for a lot of stuff if you just want flags, basically. But I really like the actual the ability to kind of have a nicely laid out like CLI structure that's kind of familiar. It's what the kubectl CLI uses. So you know, I just prefer it, quite honestly. There's other things that I've used, but this is familiar to me. You probably want to build that now, and it should just give you a standard metal. And then you want to see if we can run it. It should just give you, and then run help.
Dash help.
Dash help. Yeah. Dash help. Yeah.
Not quite.
I must have missed something here. Oh, I don't think I have an init function. That's why. That's probably not going to help. I'm very new to this. Actually, I don't think we can probably just leave this empty. Now that I think about it.
Right, let's try again. Oh, I'm in the wrong directory.
Oh, typo. Oh no, I need to save. There we go. Try again. There we go. So now we actually have the very much the beginning boilerplate of a CLI, right? And so if we want to actually run our create device thing inside the CLI, we could create a directory underneath this kind of parent directory. I have access to create directories, so I'm going to let you do this. So under Metal CLI, let's create a directory called create. And then under that, we'll go with device.
Directory or file?
Another directory. So then we're going to have like nest. And this, like the reason that I kind of have this layout is it allows you to create create a more reusable CLI. So then each one of those will have a CLI.go in them.
All right.
Is it my turn again? I believe it is. So what we're going to do here is create a standard command. So again, it's very similar to the pattern we've already have. And command equals cobra.command. Use is create. Short. Long.
I think I need to change the format of the show. It's much more fun watching other people type.
And you can always blame them if it goes wrong.
Exactly.
Yeah, absolutely. And so this is the most important thing. This runE function is basically going to make a decision about what happens when you run this command. And so that takes a cobra.command and then a bunch of arguments as a string, and it returns an error. And then here is where we're going to put our logic. And this is actually going to really only have the commands below it in it, because these create this create thing itself doesn't actually do anything. We just have subcommands in here. So what we'll do is do command.add command, and it'll be create instance.command. So then what we'll need to do here is import the directory below it. I don't actually know the full path of the import path, but it'll be... do you want to fill that out, David? Like the actual... It's from the main... Yeah, that. Yeah.
Oh, I'm in the wrong bit.
And then it's going to be the sub-package. So create...
Metal CL first, or
Metal CTL, yeah, sorry, yeah.
Create there.
Device.
And then instance. Oh, it's you're right. It is.
Yeah,
it is device. Yeah, good point. So let me change that. Okay.
So just so I understand, then this means that what we're doing here is is this supposed to be command in full? Or should this be this variable here that we're adding it to, CMD?
It should be CMD.
Yes, it should be CMD. You're absolutely right.
Okay, so the context is passing a root command, and then we can add subcommands to it, and we're adding our own.
Yes,
I'm trying to remember the path that I've gone through here. Yes, and then we also need to actually. You know what? I'm completely wrong here. We don't actually need any of this. This is why you do. Because we don't need a runE for these create commands at all, because this isn't going to do anything.
It's just a registration with the top level binary.
Right. So then this goes here. That goes there. So all we're doing, this is just we're just importing that subpackage and running it in the context of this. And so then if we open the device.command, this is where all of our logic will go.
So this gives you the ability in the CLI to be able to say metalctl create and then device as a subcommand of create.
Okay.
I promise you it'll work.
But to me, so this is device, this file, right? This is the device/cli.go, and we're referencing ourselves.
Oh, I thought I was in the create.go. That's probably where the confusion is. That's where the confusion is coming from. So all of this needs to go into the create. So in the create directory, there needs to also be a CLI.go. Right. For those people watching, I can't actually see the file name. I can only actually see where we are. So all this needs to go into there.
Okay.
And the package needs to be create at the top there.
All right. Okay. So we come into device now. This is package device.
Yeah.
And then we probably do have a run E here then, right?
Yes, that's right. Yeah.
Okay.
But let's before we actually start adding all our Pulumi logic in there, let's like actually make sure this all builds.
So
I
we
think
need
we'll
to
have
change that. Yeah, we need to
satisfy this
change that to be
first.
device. This needs to be like a proper scaffold of a Cobra command.
Yeah.
I think it still needs to run E. So how do we just do a function or expression that says hello world? What was the parameter to run E again?
Func.
Func.
Which takes a command, a CMD, which is a pointer to Cobra dot command, and args, which is an array of string.
Args.
And it returns an error. It needs to be the other way around. An array of string, not string array.
Yeah,
Go.
The TypeScript leaking through.
Yeah.
Hello.
Yeah, so that should just be hello world. Yeah.
Device create. Nice.
And let's change the use to be from create because we're inside the package of device. Let's change the use to be device.
Yeah.
Yep.
What are you moaning about, Go? Missing thing. Oh, I don't have the import. Oh, you should do that automatically. Come on, Go. Oh, VS Code, I guess. Unused command. How do we just not assign it?
No, you have to return it, I think.
Return it.
Yeah.
And it needs to be down there, yeah.
There we go.
That's what am I thinking? Right, okay. So go build.
I think we're going to have an error one level up.
Not a direct. Yeah, I think you need to remove the CLI because that's not actually. That's just the directory. It's not in the Go path. I could be wrong. Oh, we need to return a command here as well.
It's not
I believe.
it either. VS Code letting me down big time today. And
See, you're trying to take Lee and I out of our comfort zone. We're jeopardizing.
Yeah, I'm missing my IntelliJ right now.
Big time.
All right, device create. So there's a problem with this import here. So metalctl create device. Looks like
It's because device. If you go
It
back
should be
inside
command.
device, yeah, you've named it create or you've named it device as the actual package itself. So go inside, yeah, the CLI for device, and you'll see in here you've renamed it device, and it doesn't. It needs to be command. So line 9, as you look at it now, it needs to be func command.
right.
Yeah.
There we go. And I think it's because this is in the subdirectory CMD. So if you go back to your import on device.
CLI CMD, right, got it.
Yeah.
Okay.
Three professional software engineers here having a great time.
Right.
It's much harder without Stack Overflow. So then you should have
Device.
Oh, we need to import device into the root command as well.
Oh, of course. Right. So here we're going to need to add it.
It will be in the init, I think, in the configure CLI. Yeah. So in here you just need above return root command.
Line 14, as you look at it now, yeah.
So then do root command.
Add command.
Add command. Device. Command. Sorry, create command.
Yeah, create.
Not device.
No,
Sorry.
create command, not device command.
There we go.
And now the autocomplete and auto imports is working.
Yeah. So there we go. Now hopefully you can see there we have created this directory structure.
Not use create command type func cobra as argument to add command.
Interesting. Can I
Oh,
take a
I'm
look?
calling it, right? Oh, no, I need to call it. There we go.
There we go.
Okay.
Interesting.
Sure what have I got wrong?
Oh, we're all in this together, David.
Do we have to add? No, we add create, which references device. Yeah. And our main references device create. Yeah, that looks good.
See, I'm usually copying and pasting this stuff, so like I had it working once, and it was good enough. Let me.
That's okay. That looks good too. That's a binary, what we're doing. Let me pull up the Cobra docs. I'm sure it's something really simple.
Yeah, it's probably something very, very simple.
So it looks like the init function should have the root add commands.
Ah, yeah, you're probably right, actually. Well, so this the way that this is laid out is a little different to the way that I usually lay them out. If you want to open, yeah, that could work.
What are you complaining about init? Expected. Let's just try and compile it. Maybe it's just VS Code. Nope, not VS Code. It's always me, never VS Code. Oh, because I'm just not paying any attention. There we go. Right. So we still probably want to return the root command here, right?
Yeah.
Which keeps that happy. This is now complaining that root command is undeclared, and that's because here it is defined.
It needs to be that, I believe. Nope.
Have you got it? Oh, you're doing it. All right. Okay.
No, I thought that was the answer, but I was unfortunately wrong.
Oh, yeah, okay, so they create the root command in the global scope by the looks of it, whereas we're doing it in configure CLI. Let's just take...
Yeah, and it actually fires before main, so that's the trouble.
Yeah, I don't think we need that bit, right?
So we need to declare it as a var. It just needs to be equals, not colon equals.
Because of the var. Right, okay.
Yeah.
And then this is root command.
There we go.
It's not complaining.
Yeah.
That's better.
Well, it does the create command. If you do metalctl create, it might just not be showing in the help. Yeah, and then does device. If you do create device.
It's not registering them.
It's not registering the commands, but I don't understand. It's very hard to do this when you like have a established pattern that you follow.
Hold on. I am a semi-competent programmer. I can work this out. So, look at this example, right? We define our root commands, add commands, which we're doing. I mean, they don't even have a main. Oh, they just call command execute here. Okay, and the command is their module, which exposes an execute. We've got root command equals, root command execute. Looks good. So I'm assuming the init's not being called, so I'm going to call init and compile that. And that complains because
Yeah,
because
and it's
on
not
there.
a function.
Yeah,
Yeah.
I'm just going to take that out. Let's just do that. And then that's complaining because.
The import is gone.
All right, okay. That's back now.
Yep.
Build. Help. Why does it hate me?
I wouldn't mind, but I have a working version right in front of me as well. So,
Do you want to swap over, or do you want to spend another 5 minutes and see if we can fix this?
yeah, I think everybody wants to see us fix this.
All right. And if you are watching and you're pointing something out and yelling at your monitor, feel free to put it in the comments because that would be nice. Okay, so we define a root command and we add our subcommand here. Now we know this is working because we're getting create things in the Equinix Metal thing, right? It does say that.
Yeah.
Now the add command for create, which is this one here, has a func command, returns itself and adds its subcommand here. And then the subcommand does the exact same. Only this one has a run expression, which should work. So, I mean, that looks pretty fine. I'm looking at these examples and I'm like, yeah, it's good. I wonder if it's, am I building it wrong? Let's try go build.
So I usually just do go run. If you do go run, CMD, CMD metal CTL may not go. Okay, so then you do create.
Create device. So it's just my go build of everything for some weird reason. Who knows, right?
Anyway, we'll move on. Okay, so now that we have this capability to kind of create things from within the CLI, we can put a Pulumi program in our create device, like run E. So if we go back to the editor, inside our run E, and this isn't like what we were doing so far isn't even the hard part. So we were just building a very, very simple, very simple CLI. But we can import the Pulumi automation API as a Go package and actually execute it from within this function. And I believe that it is under its Pulumi. GitHub.com Pulumi /Pulumi. And then it's SDK, V2, Go, X for experimental, and then /auto. So this gives us a bunch of.
Go for it.
Sorry. This is like there's a bunch of sub packages in here as well, but essentially this is a bunch of packages that kind of give you everything that is available in the Pulumi up and the Pulumi destroy like commands essentially. So I think the best thing to do first of all is to create a there's a bunch of ways that you can create the stacks that we were doing inside the, with the previous thing. You can either reference a Git URL or you can actually have the code inline inside your function. So I think the best thing to do here is to create a stack first. So we'll need to remove the format of print line. New variable stack name, and I guess I could do this if you really want me to. Let me see if I can take over. Stack name equals auto dot fully qualified.
So Pulumi SDK isn't actually included in the Go mod here, so you'll not get autocomplete yet.
Yeah, we need to do this bare minimal and save it, and then we'll get us the complete.
And you aren't using the Pulumi SaaS backend, so we can just probably call this. Let's just call it foo for the time being. You know, because everybody loves a good variable in here. And I think, Paul, you implemented this, right, for the local backends, so it doesn't need to be /namespace or anything like that, right?
No, it shouldn't be.
Okay, excellent. And then
So
we
should we
want
build this to get autocomplete?
Yes, let's do it. Go ahead.
Yeah, so just you'll have to just return null.
Yeah.
Actually, return null, and then there you go.
And then
you can't declare to an underscore. Just remove the colon.
There we go.
There we go.
Okay, so let's get the Go mod going. Oh.
There we go.
Oh, all the Pulumi goodness coming. And we can probably just ignore that, and I'll put your stack name back.
Thank you.
And we should have autocomplete.
Exactly. And then we can create a Pulumi stack, and it comes from auto.up. We didn't seem to get the autocomplete.
It's still downloading. Yeah, I think if you just finish that bit of code.
Offset. I can probably figure it out. So this takes a context. It takes the stack name we just declared, and then it takes a project name, and we're just going to call this Rawkode Live, and then a program. So in here, this final, and I don't actually know how to do the peek in here, but this final thing in here where I'm specifying nil is where we're actually going to specify a stack. If I didn't want clean code, I could actually just literally inline my Pulumi stack in here. But what we probably want to do instead is do if error does not equal nil, return error. Make sure we're doing it all right. And then error equals Pulumi.
Lee, let's remove this fully qualified stack name. We should just declare it as foo rather than anything else. So stack name equals foo.
Probably a good idea. Agreed. Error equals. So now we've created a stack. We also need to create what we call a workspace. And this is essentially like a directory that's going to hold all of our config. So we workspace. And then in that workspace, we can do a bunch of plugin installs, which we don't actually need to do because you have them already locally. So then we do workspace dot set program, and then insert program here. In this set program, it basically takes just a standard function. So let's create func new device. And I'm going to ask for your help here, David. So the Pulumi program that we did before, we'll need to copy a bunch of that stuff from there into this new device function, essentially. And I like to namespace these into packages, but we can probably just do that in line for the time being.
Okay. Let me find where that is. So do you want the, all right, okay, got it. So
all of this goes into that particular thing, yeah. And then we should be able to do new device in here. What's that yelling at me for?
That's an extra, yeah.
Right, so it's not done our auto imports. So let's try and get a bit of help. Go mod download. Oh, cd CLI. Go mod download. Okay, and then pop back over here.
We probably also need to import.
Oh, that's the wrong config.
And we also need the v3 SDK of packet, Pulumi packet. It's pulled in. Yeah, that's probably the best thing. And line right below, there we go. Yep.
Let's save that. Oh, almost happy. So
yeah, there's no context being passed down into that func.
Yeah, so we need a Pulumi.context being passed into here, which is Pulumi's custom or specified type.
Return
and the function doesn't return anything. Yeah.
No. Okay.
I think that
as in it needs to return an error is what I mean. The signature needs to return an error. Yeah.
It's happy. Unbelievable. Oh no, it's almost.
Oh wait, no, it isn't.
Because you have to pass in context.
Yeah. Okay.
And that's not the correct context, unfortunately, because we've just newed up a context.background and we actually specified a Pulumi.context.
Okay, so does that mean, do we just initiate a new Pulumi context? Pulumi doc. I've seen a new context API.
I think actually what might be easy here is if we do var create device func equal, I'll create an anonymous function here, cdx Pulumi.context, and then return an error, and then get rid of this, and then we can do that. I think that should do it.
It's not yelling at us, so let's go for it. Go run.
What's the worst that can happen?
A few more packages.
We could bring the whole of Equinix Metal down, I guess, in a really bad situation.
Jesus, don't joke.
Pulumi stack.workspace.
Okay, so now it's moaning about our imports. So we've not got Pulumi. Oh, Pulumi's here.
You show me your imports again?
Yep.
I think the can I see the error again?
Yes, let's see. So Pulumi stack.workspace undefined. Oh, wait, is that workspace supposed to have a capital S?
Probably need to declare a new workspace.
Oh, I'm not getting any autocomplete. Of course, because it's moaning about. I mean, that's well, no, the context isn't resolving. There's multiple Pulumi resolves.
This is a very weird error.
Yeah, it looks.
Has it pulled an old version of the Pulumi SDK that doesn't have this package in it?
Let's check our Go mod. So we're pulling and
No, we're pulling to 13.2, which is correct.
That's fine, yeah.
I believe the issue is there's no function called workspace. It needs to be new workspace, right?
I don't think so. No, I'm looking at my previous attempt at this, and it seems to be.
well, I'm going to assume because the autocomplete's not working, something is not right with the imports. So what does it think a Pulumi stack is? It has no idea. Invalid type, right? So whatever this upsert stack and line, which it can't resolve either, and it's got auto going to SDK v2 go x auto.
I think this is because we removed the fully qualified stack name, which is a specific type, and it just isn't taking a string. Yeah, I think that's what it is.
Okay, so let's go try and go back to that first and see if that gives us a Pulumi stack. Still an invalid type, unfortunately. And I can't get any tooltip on this upsert stack and line function or on that. Yeah, so what's wrong with the auto import? Nothing. Should it be Pulumi X auto?
I don't think so. Certainly not looking at my my working version of something similar to this. Yeah, like I'm literally just copy and paste it from. So unless it's changed, unless it's changed recently, which I doubt.
Okay, so auto it knows is that, and then it just. Okay, so maybe this is just VS Code, right? And it's a little bit confused. So let's assume that bringing the stack name back in maybe fixed it, and then let's run the compile again.
That's going to give us a different error.
Okay, so now set program is undefined, but that's at least progress. So
Yes.
So
Oh, that's because that Pulumi stack dot workspace isn't.
What was this supposed to be again?
It should be set. Let me look back at my previous example here. Should just be dot workspace, so that should be right with a lowercase s.
Okay, so we did have an uppercase at least, so maybe that was the problem. All right, and okay, so now the fully qualified stack name.
So this is what I think Paul was trying to get us away from. So we should be able to remove. So the fully qualified stack name is expecting a. So yeah, we should just be able to put foo in there, and then remove the stack name.
Okay, it's just one step at a time.
This is professional software development.
It's working, right?
Okay, so the only thing missing from our example right now is that we have set up a workspace and set a program, but we don't actually have an up. So we probably need to actually add that because otherwise nothing's going to happen. So let's do error equals Pulumi stack dot up. CTX, and then I can't remember. This takes a so we're going to need a new
context, and it takes a progress stream.
Yes, so we're going to need a new import. And then that will need to be here. I'm going to just copy and paste it so that we can save ourselves all the time. And then we'll need also OS. And that should be it. I think that should be everything.
We just need to check the error response here.
Oh, yeah.
And then lastly, Lee, we can actually grab the value of the outputs of the IP.
So
let's call that res or output. Yeah, res is fine. Res is better because it's a response. And then we can say res.outputs. And we can grab, I think we called something from, we actually have to call into the index of outputs. So it's an array of outputs. And you can actually call it directly out by name, what we call the output further down in our application. So square brackets.
Device IP.
And then we can say dot value because we need to grab the value out of that. And the value comes out right now as an interface, so we need to string on the end. So we need to cast it to string. Dot and then in string. Yay. There we go. No toString, just string, just lowercase string.
Oh yeah.
Lowercase.
And we probably want to print it, right? So let's do format a print line. There we go.
All right, let's just ignore the errors from code. I think it's definitely very confused. Now, we don't want this to cause a duplicate device, so I'm just going to modify the host name here.
Yeah.
And we can change that a little bit to generate a random ID and pass it in if we need to.
I think it's worth pointing out at this stage, like, we're obviously just going through the process here, but because we're building this into a CLI, like we can do things like add flags, so we can give it like if we wanted to, we could have -- device name and then pass that all the way through the stack, and like it gives you that flexibility to kind of build it all into your CLI. We're just kind of bootstrapping it at the moment.
All right, so we did have someone watching our stream tell us they spotted a typo, which I've fixed. Thank you for that, mvanbus43. So we're going to run this now, right?
We're going to try it. What's the worst that could happen?
Imports, because VS Code is now confused. So
yeah,
let's see, what do we need? Do we need streamer opt up? We have opt up. PT up.
We need to declare streamer rather than set it.
Oh,
so
yeah.
We need colon equals, and we need the same on line 4 just below it. So Pulumi stack up. So we need to set.
There we go. It's because we added those variables, right?
I'll stop enabling my relative line numbers and confusing.
It's fine. I have them.
Almost there. So now it's complaining about our outputs line. Actually, progress streams is undefined. Maybe that wasn't a typo?
No, it definitely was a typo.
Right, well, let's fix the line 45 first, and then we'll see. So, it doesn't like this.
Well, I think we can probably just comment that out for the time being and actually get the thing launched and then figure out how to export the values from there.
All right.
There
so
we go.
We need streamer though, right?
Yeah.
Okay. Undefined opt-up progress streams. Let's just pull up the docs.
Did it pull the import? Did it pull?
It's definitely there. You might need to re-pull the import because you haven't ran gomod since.
Is that let's just add it to gomod manually then. I don't know, how did it get here?
I copied it in there.
All right.
It's included in the package, in the SDK v2 package. It's just that it wasn't actually grabbing it. So we should be better now.
Nope. We're so close. We've got 15 minutes. We can get this first thing created. I believe in us.
So undefined opt-up progress streams. So it knows that package is there. SDK v2 x auto opt-up. And then it just falls over.
It's 100% there. I'm actually looking at the package right now.
Can we just do a yeah?
Is there a typo maybe?
We're missing an R. So even though
Yeah.
we got corrected.
Oh, we got corrected and we didn't actually correct it properly. Awesome. Modern software development, guys.
That's fine. Yeah, it's because res isn't used. That's fine. Just make it under. There we go. Now we might get one more error here.
All right. Okay. So yeah, I'll just underscore it. Let's go back to the output in a minute. Let's get it working.
Oh, so you'll need to you'll need to change that because it's no new variable. Yeah.
So annoying. Go.
Really. Value isn't a func. That's why on the output, it's just a value dot value dot. So it shouldn't actually be a function here. That's it. That looks better. There we go.
Okay.
All right.
So we need to pass in create and device as and now we should actually have an application starting to spin up.
All right, so okay, so this is because that's password protected. No.
Yeah, it's because we'll have to actually we don't get the interactivity that you usually get with.
Now we can actually see David's password.
Oh, I see a new password. I don't need the password from the last code row, right? Oh, now I'm going to have to expose the auth token, right?
No.
Because right now there's no API key in my environment.
Yes, you probably will, yes.
All right, hold on. Let me move this over here, sneaky.
So you can't see it.
And then I'll expose this on my environment. So export packet. I can't remember if it's API key or auth token. I'm going to do both. So
there is a set config function in there as well. Like we could set it in the actual code. But
magically pull this back.
Command K, Command K, Command K.
I know. I always run PSA UX before it, so there's loads of back buffer.
That's okay. It's not a bad idea, actually. Live stream things.
All right. So Pulumi config passphrase to create device. Hopefully it picks up my token.
There's still one more error that I think we have to resolve here. We'll soon see it.
Okay. And the error is
An unhandled error occurred. That doesn't sound good, does it?
it feels like we're close though.
Oh, we have. I feel like we're close to, yeah.
All right. So it just seems to be unhappy with our inline source.
Um,
Now we did
This
change
function
that.
here.
Yeah, to this anonymous function. And it does require a project ID, which doesn't exist right now. Should we hard code this?
just hard code it, yeah.
Because we don't have a config. So
And again, you can do this within the actual.
The API itself.
Yeah, you can do it with there is a we probably won't get time to do it, unfortunately, but there is a and then you probably just don't need the config.new at all at that point.
does that still have to be a Pulumi string though? Yeah.
Yeah. Well, you've actually set it as a Pulumi string.
Yeah, it doesn't need to be just a standard string.
Further down.
You can remove config, not used anywhere else. All right, let's see what happens.
I think the other error could be we're still not using a Pulumi.context.
Nope, there it is.
No, there we go. There we go. We have an API up and running.
And now I see my debug messages that I've never seen before. So
Yeah.
So this should be creating, if we check the web, it should be creating a new instance.
there we go.
I think that's success.
That's quite why we're ahead.
So can we take a few minutes to just go over this code, what it's doing,
Yes.
and
Yeah.
then talk about what we, because I think I really do want to explore this future with my own code and my own tools and stuff like that for Equinix. So if we can just kind of cover what this is and what the potential next steps are without actually going into it, then that would be really useful, I think.
Yeah. So like when I've done this before, we've taken a bunch of shortcuts here, essentially. But like the key thing really is this auto upsert stack inline source, and we've hard coded a bunch of values here, like the project and the stack name and all that kind of stuff. But you can make this all configurable via like standard Cobra flags and arguments, which allows you to kind of make repeatable deployments. So a pattern that I think is really useful is I always use the same project name. So let's say we call this Metal CTL. As we have like Rawkode Live, we could change that to Metal CTL and then have multiple deployable instances within that same project, and then like magically generate a stack name for each one that allows you to then do things like you can list the existing stacks, you can destroy the existing stacks. It allows you to create this really repeatable pattern. But essentially that auto.upsert stack inline source allows you to pass any Pulumi program to it. And there's other mechanisms as well. Like you can do I can't remember exactly what it is, but you can have your stack in a separate Git repo, and have them be, versioned, separately, is another pattern that I think we've seen used. But essentially,
I just ask a question there?
Sure, go ahead.
All right, so I just want to make sure I understood that right, because that sounded like a pretty awesome superpower. So we're using auto upsert stack inline source, but the Git thing I thought was really interesting. So how does that work? What would that mean?
So there's other variants here, right? So you can have remote source, local source, or inline source. So it depends on where your Pulumi application that you want to execute is actually stored. So if you think of creating your wrappers, storing them in your GitHub org, then you can actually reference the wrappers from within that upsert stack command. So rather than upsert stack inline source, there'll be another function where you can actually pass in the Git remote.
Does that mean I can have multiple Git repositories, all with templates of environments like RKE clusters, Kubernetes clusters, SaltStack clusters, and I can just use some sort of Cobra flag and say, here, use this as
It's exactly it. It's exactly
awesome. It. Very, very cool.
So it's like think of it as like a central orchestrator across many sort of parts of the your infrastructure that you have to bring together, specifically pointing to different resources held either in GitHub, locally, or as embedded, exactly in what we've done today.
Sweet.
And it's also worth pointing out as well, like we've kept all of the, we've used the Pulumi Go SDK and the Cobra CLI because it makes sense to have Go in Go. But if you use the remote stack reference, you can write your Pulumi stacks in whatever you want. So if you want to provide a super easy to distribute binary, Go might be a good choice for creating ECLI. But then you can write the actual Pulumi stacks in whatever language you feel comfortable with. If you've written a bunch of TypeScript, put them in a remote Git repo, run Metal CTL up, and you're pretty much good to go. So there's a lot of stuff there. Some of the stuff that we didn't cover, for example, in this workspace thing. So if you go to on line 32, we've got workspace equals Pulumi stack.workspace. You can also automate the installation of plugins as well in the user's environment. So, David, I know you have the plugins installed already, but if you were, say, distributing this to a developer on your team or something like that, you can actually automate for the local environment the installation of the plugins they need as well. So that's all part of the kind of API that we provide, which again, it gives them the that kind of like self-service capability to just here to install this thing, and you can install best practice stuff really, really easily.
Okay, that's awesome. So let's talk about the state then that's going on here. Can this connect to all the same state backends that my regular Pulumi commands would be using?
Yeah, so it basically follows the Pulumi login that you have at the moment. So the only way that we have to interact with Pulumi as the Pulumi CLI needs to be installed on your machine. So like a good practice that I've recommended is, let's say I'm creating my Metal CTL command. I would also want to have like a homebrew tap, and I want to have a dependency on the Pulumi homebrew installation as well. And then you have to do a Pulumi login to get all your stack stuff. So you did a Pulumi login local earlier. Anybody who wants to use your command will have to do a Pulumi login to whichever backend that you're using, like the S3 backend. And then after that, it's pretty much, open season.
I mean, yeah, I'm not going to. I'm not going to say you're wrong, right? Everything you said there is right, but I've got an idea in my head is that this is just a Cobra application, right? There's no reason I couldn't have another subcommand that could automate the stack login and the downloading of the Go binary before I ever touch those Pulumi SDK components. So I could really do whatever I want to a certain degree.
I mean, you could have a Metal CTL init that basically, like, again, like one of the great things, I mentioned it earlier, like the idea around like platforms. And ultimately what we're really trying to build here is, user-friendly applications, right? And for us three, like a CLI is super user-friendly. But you can follow whatever your business logic needs. So you could do a Metal CTL init that sets your environment up, does your login, all that kind of stuff, and then you can use it, pretty straightforward. Like it's all just, I know this term is thrown around a lot, but it's all just code at the end of the day, right? Like, if you can write it, you can do it. And I think with a lot of the other kind of infrastructure as code tools that are available, these kind of workflows are either wrapped in thousands of lines of bash or they're not as user friendly basically.
Oh yeah.
Like we actually had one of our engineers at our current hack day. He wrapped this up in an Electron app and actually had a very simple UI that someone was able to launch and spin up infrastructure. And all it's doing in the background is just making the API requests in exactly the same way as we've done it from the CLI.
Okay, that's pretty sweet as well. There's just so much. What is it we call this? The automation API?
Yeah.
I mean, I can already think of a billion things I want to do with this API and the workflows that I could provide to not just end users, but my own team. Like the amount of things we could automate that were just painful otherwise.
We're very excited about this automation API. Like, I think when it was launched, it was the blog post was something called like the next quantum leap in infrastructure as code, and like it really can be. If you have this real ability that you can launch anything from anywhere, using any type of system that fulfills your environment and how your users want to use it internally, then that's really pretty cool. You can allow your designers who are not savvy with APIs or CLIs with a very simple UI, they can create multi-cloud Kubernetes clusters or whatever they need to do.
Yeah, and it's we've only interacted with one provider here, as in the packet/metal, Equinix Metal provider. There can
only be one.
No, there can be many. You can have as many as you like. Like let's say you want to create a CLI that provisions your application for your team, and they need a Cloudflare URL or something like that. We've got one resource. We could do like the BGP stuff all wrapped in here and all that kind of stuff.
Yeah, and of course this can also be used to trigger off your dynamic providers. If you've written specific dynamic providers that you need to use as part of your flow, you can embed in a dynamic provider in here as well.
Right, you're putting too many ideas in my head now. Let's. I just pasted in that code that you sent me, Paul, in the chat. So this is the example of using the Pulumi examples repository as a provider for those stack examples, right? And then we just say stack remote source, we tell it the repository, and then those become available as things I can to spin up, right? I understood that right. Yeah, okay, cool. Awesome. That was very exciting, and I can see so many different possibilities of things that can be automated now. I think it's really cool that you mentioned that we can use multiple providers there. One of Equinix's secret sauces, if you will, was interconnection to all the cloud providers, being able to spin up a JKE cluster, an EKS cluster, and one on Equinix Metal, and have them connected by a fiber backbone. is something that I'm now going to make my life's work, at least for the next 3 weeks, using the automation API.
Yeah, and you can do it all in you can call it supercluster.
Exactly.
And have a magical super multi-cloud cluster. It's really
Is it
exciting.
even a super cluster if you don't have a Raspberry Pi cluster on your desk? Though?
Well, yeah.
Well, maybe I'll try and work that bit out as well then. All right, well, we've went a little bit over, but I think it was worth it. I'm glad that we got to them, we got it working. I'm hoping that other people now see this as, a good example and basis and starting point for them to build their own really cool CLIs with this. And as you said, not even just CLIs, hooking up to Electron or even web applications that can call out and execute this stuff. Very, very powerful. So as always, I'm super impressed with the Pulumi stuff. Thank you for doing what you're doing and keep at it.
Thanks for having us.
No, my pleasure. Have an awesome evening, morning, whatever time it is in Seattle right now. Paul, you have a great time in London, and I'll speak to you both again soon. Thank you for joining me. It was a pleasure.
Take care. Thanks.
Catch you later. Bye.